Traditional electric motors use wires to conduct electricity, which can lead to energy loss through heat. Researchers are exploring new motor designs that use materials such as carbon nanotubes to conduct electricity more efficiently. Power electronics are another key component of electric cars. These devices are responsible for converting the battery's direct current, DC, to the alternating current, AC, needed to power the car's motor. Power electronics can also help manage the energy flow between the battery and other systems in the car. Research is focused on developing more efficient power electronics that can reduce energy loss and improve the overall performance of electric cars. In addition to technological advancements, the future of electric cars also involves changes in policy and infrastructure. Many countries are implementing policies to encourage the adoption of electric cars, such as tax incentives and subsidies. However, more needs to be done to address the lack of charging infrastructure. While the number of charging stations has increased in recent years, there are still not enough to meet demand in many areas. To support the growth of electric cars, more investment is needed in charging infrastructure, including fast charging stations. Another challenge for electric cars is the range anxiety experienced by drivers. While the range of electric cars has improved in recent years, it is still a concern for many people. This is why the development of new battery chemistries is so important. Batteries with greater energy density could offer longer ranges, making electric cars more practical for everyday use. In summary, the future of electric cars and the chemistry behind them is promising. While there are still challenges to overcome, such as the cost of manufacturing and the lack of charging infrastructure, research is ongoing to address these issues. New battery chemistries, such as solid-state batteries and sodium-ion batteries, offer the potential for better performance and lower costs. The development of more efficient electric motors and power electronics will also improve the overall performance of electric cars. At the same time, policy changes and investments in infrastructure are needed to support the growth of electric cars around the world. As electric cars become more popular, it is also important to consider their environmental impact. While electric cars produce zero emissions while driving, the manufacturing and disposal of batteries can have a significant environmental impact. Some of the materials used in batteries, such as lithium and cobalt, are sourced from countries with poor labor and environmental standards. There are also concerns about the environmental impact of mining and processing these materials. To address these concerns, researchers are exploring the development of more sustainable battery materials. One possibility is the use of recycled materials. Lithium-ion batteries contain valuable materials such as lithium, cobalt, and nickel, which can be recovered and reused. This approach could reduce the environmental impact of battery production and disposal while also creating a new source of materials. Another approach is the development of biodegradable batteries. Researchers have developed batteries made from materials such as paper, silk, and wood. The future of water treatment, innovations and advancements. The availability of clean water is essential for life, but it is becoming increasingly scarce in many areas of the world. While access to clean water has been a problem for decades, continued advances in water treatment technology are providing new and exciting solutions for the future. In this article, we will explore the future of water treatment and the innovations and advancements that are poised to transform the industry. From new filtration processes to emerging purification techniques, the following sections will outline the latest developments in the field. Advanced filtration techniques. One of the most significant advances in water treatment technology is the development of advanced filtration techniques. Traditional methods of water filtration, such as sand and gravel filters, have been in use for centuries. However, these methods are limited in their ability to remove certain contaminants, such as microplastics and pharmaceuticals. To address these limitations, researchers are exploring new filtration technologies, such as nanofiltration and reverse osmosis. Nanofiltration is a process in which tiny pores, less than 0.001 microns in size, are used to filter impurities from water. This technology is especially effective at removing dissolved salts and organic compounds. Reverse osmosis, on the other hand, uses pressure to force water through a semipermeable membrane, effectively removing a wide range of contaminants. While reverse osmosis has been in use for several decades, new membrane materials and designs are making it more efficient and cost-effective. Emerging purification techniques. While filtration is an essential part of the water treatment process, it is not always sufficient to ensure that water is safe to consume. Purification techniques, such as chlorination and ozonation, are used to disinfect water and eliminate harmful microorganisms. However, these processes can be expensive and energy-intensive. To address these challenges, researchers are exploring emerging purification techniques, such as ultraviolet, UV, disinfection, and electrocoagulation. UV disinfection uses high-intensity UV light to destroy microorganisms in water. This technology is effective against a wide range of pathogens, including bacteria, viruses, and protozoa. It is also more energy efficient than traditional disinfection methods, making it an appealing option for treatment plants. Electrocoagulation, on the other hand, uses an electrical current to bind contaminants together, making them easier to remove from water. This technology is particularly effective at removing metals and other heavy pollutants. It is also more sustainable than traditional methods, as it does not require the use of chemicals. Smart technologies. Advances in smart technology are also transforming the water treatment industry. Smart technologies, such as sensors, data analytics, and machine learning algorithms, are providing new insights into the water treatment process, making it more efficient and cost-effective. For example, sensors can be used to monitor water quality in real time, providing treatment plants with immediate feedback on the effectiveness of their processes. Data analytics tools can also be used to identify patterns and trends in water quality data, making it easier to optimize treatment processes. Machine learning algorithms are also being used to predict changes in water quality, allowing treatment plants to adjust their processes in real time. This technology is particularly useful in areas with variable water quality, where traditional treatment methods may be less effective. New materials and designs. Advances in material science are also transforming the water